Okay, we had in homework. So in the homework we had a table, and we want to design a circuit which implement this state table. So a state table shows that we have four states, and the next states are shown in the table: C1, B0, D0, C1, and D1. Last week we solved this example with T flip-flop, and as homework you were supposed to design a circuit based on JK flip-flop and D flip-flop to implement this table. So let's start with JK flip-flop. We already tried to reduce this state table, and we saw that it's not reducible, and then we did a state assignment for this state table, and the output of the state assignment is this table. So I'm for this part I'm going to design the circuit with JK flip-flop. So X01, Y1, Y2, 00011110, 000 010, 111, 100, 111, and 100. Okay, so first we need to know the excitation table for JK flip-flop. So JK flip-flop excitation table is shown here based on QT and Q of t plus 1. We want to find J and K. So we know that there are four different combinations for QT and QT plus 1. An excitation table is as follow: 1D, D1, and D0. So using this excitation table, we are going to design the circuit. So because we have four states, we need two flip-flops. Both are JK flip-flops. Let me double check, make sure that it's recording. Okay. Both are JK flip-flops, so we need two tables for each flip-flop. So this is the first table, X, Y1, Y2, which is for J1, K1, and the second table, which is for the second flip-flop, which is J2, K2, J2, K2. Okay, so 00011110, the same thing here, 00011110. So if we look to the original table for y1, we see that first row, first column, y1 is 0 and it remains 0 for in the first cell. So 0 0, if we look to this excitation table, we see that jk should be 0d. So we insert 0d in this table. the next cell, first row, first, second column. So y1 is 0, and the next state of y1 is 0. So again, it is 0D. So we enter 0D. Let's go to the second row. Second row, first cell, again 0 to 0, it is 0D. But if we look to second row, second column, we see that y1 is, sorry, y1 is, let me just undo this one. Okay, I'm trying to the table. So if we look to the second row, second column, we see that y1 is 0 and has is changed to 1. So we use the excitation table. 0 to 1 has jk equal to 1d. So jk should be 1d. Third row, first column, y1 is 1 and it is changed to 0, so it is d1. Third row, second column, y1 is 1 and is the next state of y1 is 1 again, so it is d0. Last row, first column, y1 is 1 and no change, so again it is d0. And finally, last row, second column, 1, 1 again is the 0. Okay, so I redo the same thing for the second table, and the values for the cells are shown here: 0D, 1D, D1, D0, D0, D1, 1D, 0D. And the third table is for the output. So third table is for the output, which is as follow. If we just look to the denominators and put them in this table. So the output of this circuit will be 0, 0, 0, 1, 0, 0, 1, 0. Okay, the first thing we should notice in this table for the output, we have two ones and they cannot be like in a group more than one cell, which is a K-map. So we consider each cell alone and we write the function. So it is x, y1 bar, y2 plus x bar, y1, y2 bar. Okay, now we return to these two tables, and if you remember, I said that again we need to split these two tables to two smaller table for each input output. So this one is J1, K1, J2, K2. Okay, and what we do, we just simply take the first digits of each cell and place it in this table. Then we take the second digits from the tables and place it in K table. Okay, so the same thing for this table. So if we do that, we will have 0, 0, 0, 1, DD, DD. Here DD, DD, 1, 0, 0, 0. For J2, we will have 0, 1, DD, DD, 1, 0, and the last table, DD, 1, 0, 0, 1, and DD. All of these are K maps. We need to simplify the functions using the K map. For the first cell, first table, we can get this one in group with D, so it's equal to X, Y2. The second one, we group 1 and D. We will have X bar Y2. For J2, what we can do, we need to group this one and this D and this one and this D. So we will have X Y1 bar plus X bar Y1, or we can show it with XOR function. So it's X XOR Y1. For K, we can get this group and this group, and of course you will have X bar Y1 bar plus X Y1. So this one, if we want to show it, it is equivalent to X nor. So X nor, or we can show it with this symbol. Okay, now that we have all functions for J1, K1, J2, K2, and of course Z, we can easily implement the function. Okay, let's implement the function. We have two flip-flops, 1, 2, J1, K1, J2, K2, Q2, Q2 bar, Q1, Q1 bar, which is Y1, okay, Y1, Y1 bar, Y2, Y2 bar. And we have input of X. Of course, we need the complement of X as well. So we can simply implement this function. J is X, Y2. So J1 is AND gate, X, Y2. So Y2 goes here, this one is Y2, and of course X is here. So this one is J1. K1 is X bar Y2. So we can say Y2 and X bar. What about J2? J2 is X, X or Y1. So we have an XOR gate, X and Y1. So we get X from here and Y1. So Y1 comes from here. This one is J2. K2 is X nor. So we can simply complement XOR and we get X nor. And that's it. We need to have the clock. The clock is connected to both flip-flops, and of course we shouldn't forget Z. Z is, if we look to Z, Z is X Y1 bar Y2 X bar X bar Y1 Y2 bar. So we need to do to apply those connections. So Z is connected to two AND gate. One of them is X. Okay, X. X Y1 bar, Y1 bar, which is here. Y2, Y2 comes from here. The second one is X bar, which we get it from here. X bar, let's see. Okay, let's just have X bar comes from here. So this one is X bar, and Y1, Y2 bar. Y1, this one is Y1, Y2 bar, and this one is Y2 bar. Okay, so this one is the circuit we implemented with JK flip-flop. For D flip-flop, again we need to repeat the same process. So for D flip-flop, let's have the circuit, let's have the table. The table is here. X Y1 Y2 0 0 0 1 1 1 1 0 0 0 0 0 1 0 0 0 0 1 1 1 0 1 0 1 0 0 1 1 1 and 1 0 1. Okay, the excitation table for D flip-flop is QT plus 1 0 0 0 1 1 0 1 1. We know that the D flip-flop only depends to the input value, not the previous value of Q of D. So if D is 0, if Q of T plus 1 is 0, of course D has to be 0, and the same thing for other combinations. Okay, now we split these to two tables. Table 1, table 2. Okay, and so this one is D1 and this one is D2. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0 0 1 0 1. Okay, now we look to the main table. Y1 is 0 and changes to 1, so 0 to 1 is 1, so D should be 1. Sorry, mm, first cell Y1 has no change, 0 0 is 0. Okay, and we complete this table. Let me double check. 0 0 0 1 0 1 1 1 1, and for D2 we just need copy Y2s from this table to this table, because we know that Q of T plus 1 is equal to D. So D should be equal to 0 1 0 1 1 1 0 1 0. Let me double check to make sure that is correct. 0 0 0 1 0 1 1 1 for first table, 0 0 1 1 1 1 0 0 for the second table. Okay. The Z table is exactly same as before, same as like here. So I'm not going to draw that one. So for this table, we need to simplify the functions. So how we can simplify this function? So this is one group, this is the other group, and this one is one group, and this one is the other group. Okay, so we can say D1 is equal to x y2 plus y1 y2 bar, x y2 plus y1 y2 bar, and the d2 is equal to x y1 bar plus x bar y1. Okay, so this is the tables, and of course this one is equal to x or y1, and we can continue and draw the circuit, which you can do that easily. It's exactly the same as what we did for JK flip-flop. Okay, this one was the solution for the homework. In the next lecture I will start a new topic.